Hello everyone. So in this video we will be discussing scalable smart contract with Diamond Proxy. So before diving it, let's first understand what is Rootstock. So Rootstock is a smart contract platform that is built on Bitcoin blockchain. It aims to extend Bitcoin's functionality by enabling the execution of smart contract similar to what Ethereum offers. So Rootstock achieves it by utilizing a two-way peg mechanism that allows Bitcoin to be converted into RSK tokens, that is RBTC, and vice versa. So this integration allows developers to create decentralized application dApps that benefit from Bitcoin security while leveraging the flexibility of smart contracts. So now let's understand a few of key feature of Rootstock. So first one is EVM compatibility. So Rootstock is compatible with the Ethereum virtual machine, allowing developers to easily port their existing Ethereum dApps to Rootstock platform without significant modification. So this compatibility fosters a broader ecosystem of decentralized application and services. Second one is smart contracts. So Rootstock supports smart contracts, enabling developers to create complex application that can automate process and facilitate transaction without intermediaries. Third one, decentralized finance. Rootstock incorporates DeFi functionalities by making it a versatile platform for developers and users alike. Fourth one is scalability. So by utilizing sidechains, Rootstock addresses some of the limitations of Ethereum network, such as high gas fees and slow transaction times, providing a robust environment for developing and deploying decentralized applications. So now let's first understand what exactly is Diamond Proxy contract pattern. So the Diamond Proxy pattern, also known as EIP 2535 Diamonds, is an advanced smart contract architecture designed to overcome the limitations of traditional proxies patterns like the transparent proxy of UUPS proxy, especially the contract size limit 24 KB imposed by the EVM and need for modular upgradability. So the core idea is like a diamond is a single smart contract system that can delegate calls to multiple implementation contracts, which are simply known as facets. So each facet consists a set of functions, and the diamond acts as a router that basically directs functions called to the right facet. So instead of one big logic contract, you can split your logic into multiple smaller contracts. So now let's understand a basic overview of what exactly the diamond smart contract is. So a diamond based contract typically includes Diamond Proxy, so which means the main contract user interact with. So it stores all data and delegates call to facet based on the selector. So here you can see like the calls are getting facilitating. So next one is Facets. So it actually contains the actual function implementation. So multiple facet can exist and each handling a set of functions. And the another one is like Diamond Storage. So it is a well defined way to manage storage layout across multiple facet to prevent collisions. The next one is Diamond Cut, which is like an upgrade mechanism, which basically allows adding, replacing, and removing function from facets, so without redeploying the diamond. And the last one is Diamond Loop, which is an introspection interface, so which basically standardize view function by inspecting facet, selector, and structure of the diamond. So let's understand how exactly this diamond proxy pattern works. So the diamond contract receives the call, then it looks up the function selector. So here first 4 bytes of call data, then it uses a mapping of like selector to facet address, and it finds which facet implements that function. Next it delegate the call to the facet using delegate call function, and finally the facet executes the function using diamond storage. So now let's understand what exactly storage management pattern over here refers to. So since multiple facets share the same storage because of delegate call, they must carefully avoid overlapping storage slot. So here each facet defines its storage using a unique namespace. So this pattern ensures storage safety across upgrade and modules. Let's understand an upgrade example of diamond cut. So here you can easily add, replace and remove function selector dynamically, where facet cut specifies which function selectors to map to which facet. Now let's understand a few advantages of this pattern. So first one is bypass 24 KB limit. So it basically split the code across multiple facets. The next one is modular upgrade. So here they can simply add, remove or replace pattern of logic independently. The next one is single address for user. Here user always interacts with one proxy address. The next one is gas efficient upgrades. Here only specific facets are redeployed. And the last one is extensible and maintainable. It is easier to organize into the large project which consists of a heavy code base. Now also let's understand a few disadvantages of Diamond Proxy pattern. So first one is complexity. So mapping selector and storage across facet is non-trivial. Next one is testing overhead. So here upgrades require careful testing to avoid state conflicts. The next one is learning curve. So it is harder to understand for the new developers, but no worries, I will give you a proper example of the code and contract how we go through, so it will be very easy to understand. And the last one is tooling limitations. So not all framework like Hardhat or Foundry have first class support yet. So there are multiple proxy patterns in industry, like there is transparent proxy, UUPS proxy. So let's now basically compare between three as of now. The first one would be the transparent proxy, the second one would be UUPS proxy, and that one is our favorite Diamond Proxy. So for the number of logic contracts, transparent proxy and UUPS proxy just support for one single logic, but Diamond Proxy consists of multiple proxies, contract logics. The next one is upgradable. So all three supports upgradable feature, but Diamond Proxy supports a more modular support. The next one is contract size limit. So in the transparency and UUPS proxy, there is no as such limit on the contract size, but in Diamond Proxy there is, but it also splits across multiple facets. Now considering the complexity feature, transparency proxy has less complex and the UUPS proxy has medium level of complexity, we can say. The Diamond Proxy has a high level of complexity, and considering the modularity functionality, so the best one as of now is the Diamond Proxy with high level of modularity. Now we understand all the understanding of the Diamond Proxy pattern, its advantages, its disadvantages, how it actually works, it comparison with multiple proxy patterns. Now let's understand when to use the Diamond Proxy. So the major use case is like when your contract system exceeds the 24 KB limit, it is always good to use the Diamond Proxy pattern. The another way of using it is like when you need modular upgrades, example adding new feature, you should then choose Diamond Proxy pattern. And the last one is like when you are building large scale application like DeFi protocols, DAO or gaming system, it is always good to use Diamond Proxy patterns. There are multiple reasons as of now, but we have gone through just overview of few major reasons why to use and when to use the Diamond Proxy pattern. So now let's understand what actually delegate calls are in the Diamond Proxy pattern. So the delegate calls are the blockchain backbone of the Diamond pattern, enabling a contract to execute function from another contract while preserving the calling contract storage context. So let's understand in a detailed breakdown way. So the mechanism is like a delegate call invokes a function in a target contract but uses a caller storage, a code and balance. Unlike the regular call, it doesn't create a new call frame, allowing the target contract to modify the caller state. The next one is syntax. So in Solidity, delegate call is used with low level assembly of flexibility. So like its syntax would be, so let's understand it. So it is defined like bool success, then bytes memory with return data, which would be equal to the address target delegate call data. So like now let's understand use in diamonds. So the diamond contracts fallback function use delegate calls to route the incoming function calls to the appropriate facet based on the function selector. So first 4 bytes of the call data. So let's now understand risk. So storage collisions. So if facet use the same storage slot, data corruption occurs. The diamond proxy mitigates this with a standardized storage layout called as diamond storage layout library. There is one another is called as retrancy. So Facet must follow the check effect interaction pattern to prevent retrancy attacks during delegate call. So one major benefit of this delegate call is it enables dynamic function execution with code duplication critical for diamond modularity. So basically this video will implement delegate calls to route marketplace function, ensuring developers understand their role. Also, I will help you identify the prerequisite for the Diamond Proxy project that we are building. So now before directly diving into developing a contract and deploying it, let's first understand what all packages and developer tools that we will be using in our project. So first one is like we will be needing Node.js. So if you don't have Node.js, simply head on to the Node.js website and simply click on the get Node.js. From here you can download the Node.js. The another one is like npm, which is an package manager for the Node.js. So you can simply get it from here, and you can also get proper understanding like how npm works and everything from here. So and the major development tool you will be needing over here is Hardhat. So Hardhat is basically a smart contract development framework. And the final one is like Git, which we will be using like while pushing up the code, and which is like an free and open source distributed version control system designed to handle everything from like small to very large projects with speed and transparency. Also now let's come with the prerequisites that are related to the blockchain concepts. So here the wallet we will be using will be the MetaMask. So if you don't have MetaMask wallet, you can simply head on to the metamask.io website. From here you can simply get the wallet, and you can just simply get your wallet into your Chrome extension. I highly recommend you to like pin the extension from the Chrome or Brave, whichever browser you will be using. So it will be like handy while interacting with the contract. Also like here we will be interacting with the Rootstock Testnet. So you can just grab on the details from the Rootstock details. So you can just connect your wallet, and you need to simply check on the include testnet. So from here you can basically get all the chains of Rootstock. The first one is mainnet and the next one is the testnet. Yeah, so here you simply need to click on the add to MetaMask button. So it will add Rootstock testnet chain to your MetaMask wallet. Also, like while interacting and while deploying the contract, you need some testnet tokens. So you can simply grab it on from the faucet of Rootstock. So you simply need to head on to the faucet.rootstock.io, and you simply need to paste your wallet address over here and simply confirm that you are not a robot, and hit on the get test RBTC. So within 30 seconds you simply get your testnet tokens collected into your wallet. And one thing, like we will be creating a .env file where you will be needing your private key. So you can simply head on to the Rootstock into your MetaMask, and simply from there you can into the account details you can get your private key. So here you just need to click and you need to hold until the box gets checked, and you need to type in your password, then it will reveal your private key. So in .env file you simply need to copy that private key and paste it over there, which we'll be needing while deploying our contract. So now let's start with creating the project. So here I will be using cursor as my default ID. So first you simply need to create a project. So here I will be creating a new folder. Let's name as RSK Diamond. So now let's first initialize the Hardhat. So the command for the same is npx hardhat init. So it will initialize the Hardhat project. So basically the Hardhat is a development environment and task runner for building, testing and deploying smart contracts. So think of it like as a complete toolkit for blockchain developers. So here we will be using Hardhat, and similarly here we will be using the JavaScript using Mocha and EtherJS. So now it will install the required dependencies. So now let's understand few of the files that Hardhat initialized. So the first one is the contract folder, which consists of a log.sol file. So it is an basically example of solitary contract to test compilation and deployment. The next one is the test log.js. So it contains automated test cases for the contract using Mocha and Chai. The next one is hardhat.config file. So it is basically a configuration file which defines the Solidity version, networks and plugins. The next one is package.json file. So it consists of Node.js metadata, which basically manages the dependencies and npm scripts. And the last one is a readme file. So it is basically a simple guide that instructions for using the project. There are some addition folders like node modules, which basically store some of the installed dependencies like plugins. So now let's first start with adding the configuration file. So let's add a setting with optimizer over here, optimizer, and let's make enabled value as true, and also it runs with 200. Now let's add the networks. So here we will be using Rootstock Testnet. So let's name it as RSK Testnet, into which we will be adding the URL. So we can easily get this URL on Rootstock official documentation. So as we have already mentioned that we will be creating an env file into which we will be adding the testnet RPC URL and the private key. So here we will be directly using it. So Rootstock has its chain ID as 31 for testnet. Let's make the verbose value as true, and for account here we will using the private key. So we have successfully written the config file which we will be using while deploying the contract. So now let's implement the Diamond Proxy contract. So the Diamond Proxy contract requires a core contract, storage library and Facet to enable modularity and upgradability. So let's explore why and how these components are essential and implement them. So like why and how the Diamond pattern requires a core contract in a single contract address that can handle an infinite number of functions. So on Rootstock, this pattern takes advantages of Bitcoin backed security on Rootstock while utilizing the EVM capabilities. On top of that, the Diamond design depends on three essential elements to accomplish its objectives: the Facet, a storage library, and a core contract. Let's look at each necessity and how they complement one another below. So first one is like core contract and why it is required. So basically the Diamond or core contract is the main point of entry for all communication with the smart contract system. So it's a single address where users and other contracts interact with by providing a unified interface. Also, it handles function routing by the using a fallback function to delegate calls to the appropriate facet, enabling modularity without a core contract where it would be like no central mechanism to manage the facet or route function call. And for long-term dApp, its maintenance, it guarantees upgradability by permitting the addition or removal of additional facet without altering the contract address. So now let's understand like how it actually works. So the core contract diamond.sol. So like parallelly we will be like creating the diamond. So basically this contract contains a minimal logic, includes a fallback function that intercepts all incoming calls. It uses delegate calls to forward these calls to the appropriate facet based on the function selector. The first 4 bytes of the call data are derived from the function signature. It also supports a receive function for handling ether related payments, which is like necessary for dApps like marketplace where payments are involved. And the core concept interacts with the storage library to determine which facet to delegate to and ensuring that all calls operate on a shared state. So let's start with writing the core contract of Diamond.sol. So here first we will be defining the license required. Here we will be using the ABIT license. Now we need to define the Solidity version that we will be using. So as of now we will be using the version as 0.8.20. So now we will be defining the contract. Let's name it as Diamond, into which we will be using the Diamond storage for Diamond storage dot Diamond storage struct. Now let's define a constructor. So basically the constructor is called only during the deployment. So let's write the constructor now with parameter as address and diamond cut facet. So now let's access the central Diamond storage struct. So for it, first we need to access it from the Diamond storage, and where the storage ds would equal to the Diamond storage dot Diamond storage over here, and basically this would be a function call to the function. Now let's set the contract deployer as the owner. Now let's add the initial facet like Diamond facet, which allows adding and removing the other facet by just simply writing bytes 4. Now let's write a function selector for Diamond cut address bytes of 64, to which we are using the kcalc2, and into which we will be passing the address bytes 4 with an array, empty array, and the bool. So now let's map the selector to its facet address. So for it we will be simply writing ds, into which it accepts an array with selectors from the 0th address, and then simply the which would be equal to the Diamond cut facet selectors 0, which means it like access the value from the 0th index of the array, and let's be equal to the selector. Now let's write the fallback function, which is triggered when a function is called that doesn't exist in the contract. So for it we simply write a fallback, and which would be an external payable. So let's now access by Diamond storage dot Diamond storage struct storage, which would be equal to be the, let's first define a ds over here, then which would be equal to Diamond storage dot, and it will be calling the Diamond storage function. Now let's extract the function selector, like the first 4 bits of the call data. So byte 4, let's name the variable as selector, which would be equal to message dot. Now let's find which facet logic contract implements this function. So address facet equal to ds, into which we will be passing the value of the current selector, and then simply calling the facet address. Now let's write a logic to revert if the function selector does not exist. So we simply write to a require facet not equal to address from the 0th position, and then passing function not found. Now let's write the delegate call to forward the call to the facet while keeping storage as the Diamond itself. So for it we simply write the assembly, and then for the logic one, let's define a pointer with mload of 0x40, and then call the data copy with pointer 0 and call data size. Now let's write the delegate call to the facet contract, for which we will be simply defining a variable called result, which will be calling the Diamond delegate call with gas facet pointer and call data size, and simply the rest of the variable let's pass it as 0. Now let's copy the return data. So for it we will be initializing a size variable which will return the size data, and then let's for the same call the parameter with pointer 0 and size. Now finally we will be like handle the success or revert values. So for which we will be writing a switch result, and based on that, if the case is 0, simply revert with pointer and size, and if the value is default, simply return pointer and size by default. And finally we will be writing a receive function for plain ETH transfer. So now let's understand why this matter. So the fallback function extract the function selector like the message dot sig and looks up the corresponding facet address in the storage library. So the ds facet selector equal to facet address. So we defined it basically execute the function in the facet, ensuring the call operates on the diamond storage. So like now let's understand how it functions. So when a user call list item with value as 1 beaded necklace and the value is like 0.0 ether, so on the diamond contract address the fallback catches the call, identifies the listen item selector and delegates the call to the marketplace facet, which later on executes the logic while modifying the diamond storage. The next, like we use storage library. It is required for diamond pattern to need a centralized storage mechanism to ensure all facets share the same state without a storage library. So here each facet would have its own storage layout, leading to a collision and data corruption when delegate calls modify storage. And a storage library basically enforces a consistent storage slot across facets using a specific slot identifier with an algorithm of KK256 to prevent overlaps with other variables in the diamond contract or facet. So it also enables the core contract and facet to access shared data like listing items, prices securely and consistently, which is critical for the pattern modularity. So now let's understand how it works exactly. So the storage contract defines a struct to hold shared data and mapping to track facets and their function selector. So let's now write the another required contract. So it would be the diamond storage. So similarly here we will be defining the license and the solidity version that we will be needing. Here we will be using the version as 0.8.20 and let's first define the license identifier. It would be MIT. Next, the pragma solidity version would be 8.20 as we used it while writing our earlier contract. Now simply defined a library called as diamond storage. Now let's write a struct that holds the facet address and its function selector. So now let's define the address as facet address. So let's write address then facet address. It is the address of the facet like logic of the contract. Then simply define the selector. It would be like bytes 4 and then array of it. So this selector is the list of function selector handled by the facet. Now let's write the main storage structure used by the diamond contract. So let's now first write the diamond storage struct, and then into which first we need to write the mapping from function selector to its corresponding facet and selector, for which we simply write mapping from bytes 4 to facet address selector, and here we will be writing facets. Now we will be writing the mapping to keep the track of supported interfaces like of 165 compatibility. So here we need to write mapping addresses of bool, and then we need to write the supported interfaces, and finally we need to write address of the owner, like which has the permission to perform diamond cuts and etc. Now we simply write the example of shared state that all facets can access for a marketplace use case. So for which we will be writing mapping of uint 256 to string with items like item id where refers to the item name or metadata. Then we will be writing the mapping from uint to uint 256 with prices value. Now let's write a function diamond storage which returns a reference to the single shared diamond struct diamond storage struct in a contract storage. So for which we will be writing a function called as diamond storage, and then into which we will be writing internal pure returns with diamond storage struct with storage ds, and finally here we will be defining a unique storage slot for diamond storage using a hashed key. So let's name it as bytes 32 position equal to, we will be using the Kekas algorithm and simply passing the value of diamond storage, and finally here we will be writing the assembly which assigns the struct to the specific storage slot, which would be like ds dot and here the position. So now let's understand why this diamond storage matter. The diamond storage struct basically includes a mapping for Facet to store the functions, selectors and their corresponding Facet address, as well as the shared state for the marketplace items and prices. The diamond storage function uses assembly to map this struct to unique storage slot KK256 diamond storage, ensuring consistency across facets. So let's understand how this works. So when the marketplace facet calls listen item, it uses diamond storage to access the shared storage and writes the item name and price to DS items and DS prices. Similarly, the payment facet read the price from DS prices to verify the payment, ensuring both facet operate on the same data without any. So like multiple times I am using like facet. So let's now understand why they are required. So facet are a modular component that contain the actual business logic, that is listing price, processing payments. So they allow the diamond pattern to split functionality into separate contracts, overcoming the 24 kilobyte size limit and enabling modularity. So without facet, all logic would reside in the core contract, making it monolithic, had to upgrade and prone to hitting size limit. So facet allow developer to add, remove and update features independently. So they enable fine-grained upgrades, like by updating the payment logic without touching the listening logic, and also while maintaining the single contract address for user. So now let's understand how they work. So each facet is a separate contract containing specific function, that is listen item in marketplace facet, process payment in payment facet. So these functions are called by delegate calls from the core contract, so meaning they execute in the context of diamond storage. So now like facet uses the storage library diamond storage to access shared state, ensuring consistency. So they don't define their own storage variable to avoid collisions. And finally, the diamond cut storage manages the addition and removal of facet, updating the mapping in the storage library to reflect which functions are routed to which facet addresses. So now let's create two folders. The first one is facets and the another one is libraries. So let's add this diamond storage into libraries. Now we will be creating three files into our facet. First one is the marketplace facet.sol. The another one would be the payment facet.sol, and the last one will be the diamond cut facet. So let's first start with the marketplace facet.sol. Marketplace facet.sol. So here first let's define the license identifier as MIT, which means we will be using MIT license. Now let's simply define import the diamond storage from the libraries. Now let's define a contract name as marketplace facet, into which we will be writing an event as like item listed, which gets emit whenever a new item is listed in the marketplace. So let's simply write the event and let's name it as item listed with the and the string with name and u into 56 with price. Now let's write an function for listing the item. Writing the function with name as list item. We will be passing the parameters as item ID, the string with variable name, then finally the variable as price, and the function would be an external function. now we will be getting a reference to a shared diamond storage. So for we will be simply using the diamond storage struct and storage of ds to diamond storage function. Now let's save the item details into the shared storage. So we simply need to write ds.items with respective item id equal to name, and similarly for the price ds.prices with respective item id equal to price. And finally we will be writing an emit event for UI frontend to track new listings. So for the same we will be writing emit item listed with item id, name and price. Now we will be writing another function for fetching details of the item listed. So let's name it as get item. Let's pass the parameter as uint 250. Let's make it as external view returns, and it will return string memory and uint 256. And let's finally access the shared diamond storage struct storage ds equal to diamond storage, and let's finally return the stored item details with ds.atoms with item id and the ds with item id. So here we successfully write first marketplace facet. Then next we will be writing the payment facet for processing the payments. So let's name it as payment facet. So similarly we will be first writing the MIT license and the Solidity version. So next we will be writing a contract name as payment facet defining, and where we will be writing an event which will emit when a payment is successfully proceed. So let's write an event name as payment processed with uint 250, passing parameter as item id, then buyer, and finally the amount. Next we will be writing a function as process payment with parameter as item id, and this function would be an external payable function. Now let's access the shared diamond storage from the diamond storage contract with storage ds equal to diamond storage, and let's finally retrieve the price of the item from the shared storage using uint 256 price equal to ds dot prices, and let's pass item id into it. Now we need to ensure the buyer sends the correct payment amount. So for this we simply write a require statement with message value equal to price and like writing incorrect payment amount. And finally we will be emitting a event for tracking and off-chain integration. So let's write an emit function naming as payment proceed with item id, message dot sender, and finally the message dot value. So here we have successfully returned the payment facet. Now let's finally write the diamond cut facet. Let's name it as diamond cut facet dot sol, into which we will be simply defining the MIT license and the Solidity version. So let's first now import the diamond storage contract that we wrote in the libraries folder .sol, and let's start with writing the contract for the diamond cut facet. And here first we will be writing an emitted event, so whenever a facet is added or removed. So for this we will be simply writing an event name as diamond cut with passing the address index facet, and the another one would be selectors and added. So it would be of data type bytes 4 and selector, and finally it would be bool with variable name as added. Now let's write a function name as diamond cut, which basically adds or remove selector from the diamond. So let's define the function with name as diamond cut, into which we will be writing the parameters as facet with data type address, and next we will be writing the bytes 4 with call data of selectors, and finally the bool variable with add variable. Let's make this as a external function. So let's simply write external over here. So now let's write a diamond storage event to access the shared diamond storage. So for it, we simply write diamond storage or diamond storage struct where storage ds equal to diamond storage equal to ds dot owner, and writing only owner as parameter. Finally, we will be writing an if condition for add or update the facet functions. So simply we will be writing an if statement with underscore as add, and here we will be writing an for function which will select selector and link each function selector to the facet address, and also it's optionally but to store all selector for a reference or management. So let's define a for statement with uint6 I equal to 0 and I must be less than equal to selectors dot, and finally we will be incrementing the value of I. Now let's define the selector which should be equal to underscore of I. Now let's link each function selector to the facet with selector dot facet address should be equal to underscore of facet, and finally it's optionally but we also store the selector for the reference or management. It will be simply ds dot facet selector of selectors which will equal to underscore of selectors. Now let's write the else statement into which we will be writing function to remove facet functions. So simply writing the for statement will less than selectors dot length, and finally the increment in the value of I. Now let's delete the facet with selectors of passing the value of I, and now let's write a emit function to emit an event to signal the update which basically adds or removes. So for it we simply write the emit with diamond cut function with parameter as facet selector, and finally the add one. So we simply here return the diamond facet cut facet function. So why, let's understand why this marketplace and payment facet function contracts are implemented. So basically they both implement specific marketplace feature like listing and paying. So while the diamond cut facet enables upgrade by modifying the facet mapping in diamond storage, each facet uses delegate calls by the contract fallbacks to execute its logic in diamond storage context. So now let's understand how they basically works. So when a user listens on the diamond, the fallback delegates the call to marketplace facet, which writes to shared items and prices mapping. Similarly, a process payment call is routed to payment facet, which reads the price from prices to verify the payment, ensuring seamless interaction across facets. So now let's understand how these components work together. So first, the core contract as the entry point. The diamond.sol contract receives all calls and uses its fallback function to route them to the appropriate facet while delegate calls based on the function selector stored in the diamond storage. Second, the storage library as the shared state. So diamond.storage sol ensures all facet and the core contract operate on the same state. Example like item prices by defining a single contract slot, avoiding collision during delegate calls. Third, the facets as a modular logic. So facets like marketplace facet and payment facet contain the business logic, while the diamond cut facet enables upgrade, allowing the system to evolve while redeploying the core contract. So let's now understand all the components with the flow example. So in a simple way, when a user call listen item function with value as 1, bearded necklace and 0.01 ether on the diamond contract, the fallback function in the diamond sol extract the selector from the listen item and looks up the facet address, which is the diamond storage.sol and the marketplace facet. So it performs the delegate call to the marketplace facet, which executes the list item and updates the shared storage. And finally the payment facet can later read the price from prices to process a payment, demonstrating why shared state across. So now let's understand why this structure is essential for the diamond pattern. First one is for the scalability purpose. The core contract and facet allow unlimited functionality without hitting size limit as such as Facet can deployed separately. The next one is upgradability. So here the diamond cut facet allows Facet to be added or removed, ensuring the dApp can perform and grow without changing the address. The next one is consistency, which is very important. So the storage library ensures all Facet share state safely, a necessity when using delegate calls that modify the caller storage. And the last one is flexibility. So developers can add new feature, example review system as a new facet, keeping the system modular and maintainable. So this structure makes the diamond pattern a strong tool for Rootstock developers, enabling complex upgradable dApps like marketplace. So now let's create the interaction.js script, so which will be used for the development purpose. For the same, I will create a folder name as script, into which I will create a file name as interaction. So now let's first use ethers from the Hardhat. So these are all the packages that we installed prior while initializing the Hardhat. Now let's write an async function. It would be a main function. As of now, we won't be passing any parameters into it. Ethers dot, which will get the deployer's account. Basically it returns an array of account. So we first take the first one. So let's first complete it. Get signers. Now let's define a const deployer, which will equal to the await ethers dot get signer. Now let's write the deployment part for the diamond cut facet. So we will be defining a const name as diamond cut facet, which will be equal to await ethers dot get contract factory, and into which we will be passing the value of diamond cut facet. Now let's define another constant name as diamond cut facets. Keep it as same, but just we will start the initial value with the small, which will be equal to await diamond cut facet dot deploy. Now let's wait until the deployment happens. So for it we will simply write diamond cut facet dot. Now we will simply log it, console.log, into which we will be writing facet deployed to and the target value of it, which is diamond cut facet dot. Now let's pass the diamond cut facet address to the diamond constructor. So here we will be simply writing a diamond, defining the diamond constant. Here we will be awaiting until ethers get the contract factory, and we will be passing the diamond. Or else what we can do, we will simply await. We will first, we will get contract factory with the diamond, and then we will be simply writing const diamond equal to diamond dot ethers dot deploy, and similarly the diamond cut facet dot deploy dot target. Now we will be wait until the diamond contract gets deployed, diamond deployed to, and the diamond dot target. Now let's attach the diamond cut facet interface to the diamond proxy. So this allows us to call diamond cut on the diamond contract. So we will be simply writing a const as diamond cut facet, which will be equal to ethers dot get contract at, and we will be passing the value as diamond cut facet and the value to it as diamond.target. Now let's generate this selector for the diamond cut dynamically. So let's name it as diamond as cut facet. So it can be done using defining a const with diamond cut facet interface, which will be equal to new ethers dot interface, and here we will be passing the value of diamond cut facet dot interface dot format. Now let's define a const name as diamond cut function, which will be equal to diamond cut dot get function, and we'll be passing the params as diamond cut. Let's make this ts small. Now let's define a variable as diamond selector, const diamond selectors, which will be equal to array of diamond cut function dot selector. Now let's add a deployment facet cut to the diamond proxy. So for which we will be simply writing await diamond cut as facet dot connect. We will be passing deploy to it, and then simply again diamond cut, into which we will be passing the value params as diamond cut facet dot target, the diamond cut selector, and finally the true value. Now simply log it, making as diamond cut facet at diamond proxy. Now let's deploy the marketplace facet. So what we can do, we can simply make changes into the above written code. Instead of just marketplace diamond cut facet, we will be replace it by marketplace facet in the all places. Similarly here also we will be doing the same, and finally here just deploy it to the, here we will be using as marketplace facet. Similarly here also, and yeah, we are good to go. Yes, so we have now successfully write the deployment for the marketplace. So now we need to generate the selector for the marketplace. So we can simply copy the selectors of diamond cut. So we will be just replacing the words for the marketplace. We're not needing this. So instead of just diamond cut, make it as market cut or marketplace facet interface. Similarly, we will be just changing the values here. Instead of the function, let's make it a diamond list item function, and here we will be changing as marketplace facet. Now here we will be writing the constant as get item function, into which we will be using the function of list item function, and also we will be passing the get item. Oh yes, first we need to define the get item function, which would be similar to this, but just we need to pass it as get item. Here we will be making change as get item, and above it we made as list item. Instead of list, we will be simply changing it to get. Yeah, and here we will be making as marketplace selector, and similarly here we will be passing get item function dot selector. So we have successfully defined the selectors. Now let's add marketplace facet to the diamond proxy. So to go ahead with, let's first write await diamond as cut facet dot connect, and then pass it deployer, and then diamond cut, and finally pass as marketplace facet dot target, and then marketplace selectors, and finally the value true to it. Now let's log it. Let's log it as marketplace facet added to diamond proxy, marketplace facet added to diamond proxy. Now let's deploy the payment facet. So to do it, we can simply copy paste the same of marketplace and just replace the values to the diamond facet. So let's start over here. So here we can simply change the value to the payment facet, payment facet, and we can simply change over rest of the places payment. Let's make this PS small. Now let's change this value to payment and wait for deployment, and here we can change the value. Similarly over here we need to change the value. Let's make this PS small. So now we change the values for the deployment of payment facet. Now let's also change the values for the generate selector for payment interface. Also change this value to payment facet, or we can also write it as like process payment function, which is equal, here we need to change, here also we need to change, and finally over we don't need the get item. Here simply we can replace it with here, and simply here what we can write is payment selector, and over here we can write as process payment function, and there will be no need of the second value. Also here we can write it as process payment. So yes, so finally we have written the generate selector for the payment facet. Now let's add payment facet to the diamond proxy. So similarly we just need to change the value. Here we need to write payment facet true, and like here simply we need to run the deployment script to catch the error, and next we will simply logging the error. We will be adding error to it, and finally we simply write to need process exit code with value as 1. So now we have successfully written the deployment script. So yes, we are now good to go with the deployment. So now let's deploy the contract of Diamond Proxy. So we simply need to write the command as npx run script slash interaction.js and the network that we defined in the Hardhat config file. Now our contract is getting deployed. So let's see like a few key takeaway for interaction. So to access the marketplace functionalities, including displaying things or making payments, user or external application like a dApp frontend need to only communicate with Diamond contract address. So now you can see our contract has been successfully deployed, and this is the contract address. So in order to preserve a single point of contact for the whole system, the Diamond pattern makes sure that all calls to this address are routed to the appropriate facet, by which user should call the other addresses like Diamond cut faucet, marketplace and the payment facet directly, because they are internal components that are controlled by the Diamond contract or the other contract during updates. So yes, we can see the Diamond cut faucet has been successfully deployed. The Diamond contract also has been successfully deployed. Now we will wait for our marketplace facet to get deployed. So now you can check the Diamond cut facet also get successfully added to the Diamond Proxy. Then the process that will be taking place would be our marketplace facet will get deployed. Then it also get add to the marketplace of will get added to the Diamond Proxy, and similarly at last our payment facet will get deployed to a contract address, and similarly it will get added to the Diamond Proxy. Yes, now you can see like our marketplace facet has been successfully deployed to the address, which is this. So we need to like save this contract address which will be used while interacting with the contract. Now we can see like it's running the script to add the marketplace facet to the Diamond Proxy. So like if you want the further development in the same Diamond contract, you can like use gas optimization method. Like you can simply make the batch facet addition, which will basically add multiple facet into a Diamond cut call to reduce calls. Then you can also selector efficiency, which will be use a mapping to cache selectors, avoiding repeated lookups, and also finally we can do gas profiling, which will update the gas optimization. So yes, you can see like marketplace facet has been added to the Diamond Proxy. Now it's deploying our payment facet to the Rootstock Testnet. So in further, if you want to deploy it to the Rootstock mainnet, you simply need to change the RPC URL and chain ID from the Hardhat config we defined. So there you simply need to write the chain ID as 30 and simply need to copy the RPC URL from the Rootstock official doc or the chainlist.org website. So here you can see the payment facet has been successfully deployed. Now the final stage is it is adding market payment facet to the Diamond Proxy. Once it's done, like we are good to go with the integration purpose. So yes, you can see like payment facet has also been get added to Diamond Proxy. So we here successfully wrote the Diamond contract and the other contract like marketplace facet, payment facet and the Diamond cut facet, and successfully deployed. So if you are facing any doubts or have any queries, you can simply join Rootstock Telegram and Discord and ask your doubts under the respective channel. Also Rootstock have their curated documentation. You can simply go and navigate over there. Also Rootstock have their own AI chatbot where you can simply ask your doubts and get it resolved in real time. So thank you everyone. Happy coding.